Hi there, it's time to get up to scratch. Today, we're going to look at the New Zealand Curriculum for Computational Thinking, Progress Outcome 3. This video is for students who want to show they have achieved this outcome or for teachers who want to learn more about how to assess their students. Let's begin. Progress Outcome 3 says, in authentic context and taking account of end users, students decompose problems into step-by-step instructions to create algorithms for computer programs. They use logical thinking to predict the behavior of the programs, and they understand that there can be more than one algorithm for the same problem. They develop and debug simple programs that use inputs, outputs, sequence, and iteration, repeating part of the algorithm with a loop. They understand that digital devices store data using just two states represented by binary digits or bits. That is quite a lot of words, so let's deconstruct that into some of the most important bits of the definition. Let's first look at this phrase, decompose problems into step-by-step instructions. Now, decomposing a problem is one of the four main parts of computational thinking. Basically, to decompose something means to break it down into smaller parts. So you're breaking down what you want your program to do into one step at a time and being able to put those into instructions. Debugging basically means that you need to go through your code and figure out where the mistakes are. Every single programmer that has ever made a program has made an error, and the important part is that you learn how to examine your code and to make it better. So that's just going to become a natural part of your process when you are creating scratch programs, and the more and more that you do it, the more that you will get better at it and learn little tricks. The last phrase we'll look at in this definition is use inputs, output, sequence, and iteration, which means repeating part of the algorithm with a loop. Now, we talked about outputs and sequence in progress outcome 2. So if you're not sure about what those are, you should probably go back and look at that video. But inputs are basically that the user is doing something. So they're inputting something. So maybe they're writing an answer, maybe they're clicking a button, maybe they're moving a mouse. So we're beginning to now create programs that are a little bit interactive. They're not super interactive at this point, but there's a little bit. Iteration and that whole part about repeating part with a loop, part of the algorithm with a loop, is where you will have a bunch of code that might happen a few times over. So rather than copy and paste the code over and over and over, you can repeat it with a loop block or a forever block. And we will look at that in a few of our examples later. The last bit that I want to talk about here is the using binary digits for devices. Now, that's not something we can really interact with in Scratch. It's something that you probably have to learn offline, or you could probably watch a video. So in the future, I might revisit that concept and explain what binary digits are and how computers use them. But for now, I'm going to leave it at that. The blocks that we'll need to use to show that we have achieved progress outcome 3 are starting to grow a little bit now. So in progress outcome 2, we said that you'd probably need the move blocks, the looks blocks, the sounds blocks, along with the first event block. Now we can start to include the rest of the event blocks because, as I had mentioned in that video, they are mostly ways of putting input into your program. And we're going to add a few more of the control blocks. So we've been using the wait block, and using the repeat and forever now is what we're going to add. And if you slide down a little bit, you probably can start using the when I start as a clone, create a clone of myself, and delete this clone block. And we are also going to start looking at some of the sensing blocks, but particularly this ask and wait block, as well as the answer block. And a small little bonus with the operator blocks, there's one block here that I really like to use, and it will be really helpful when we're using the sensing block, is the join block down here. So let's take a look at a few examples of ways that we can show that we understand progress outcome 3. So in this example, I've created a program where the program will ask the user some questions and respond with those answers. So let's have a look at what it does. So it says hello to me and asks what my name is. So I type my name in and it says, oh, hi, Michael. How are you feeling today? And I'm going to say happy. Oh, I didn't know you were feeling happy. What's your favorite game? And even though this isn't my favorite game, something has gone wrong there. So I put my favorite game in. So what the mistake that I made here, and again, this is a great example of debugging, is instead of asking for something, I've actually said that instead of waiting for a response. So there's nothing to actually say there. So this is an example of a program using a repeat block here. So I've created this dancer, and there are some sprites that have multiple costumes. So I think this one had 13 in it, and I've set the size to 75%, and I've had her start in the middle. I started a song, and then 30 times I'm waiting for zero point 0.2 seconds. I'm going to the next costume, and then I'm changing the size by 1%. So after that 30 times, it'll be roughly 105%. Let's see what that looks like. This is way more efficient than copying and pasting these 3 blocks 30 times. So you can see how loops can make things a lot easier on your programs. So in this program, I've used 2 sprites again, and I've combined a few different interactive elements to this. So in this sprite, Gobo, I've created a when the space key is pressed, it creates a clone, and then it will do some things, including a loop. And on Nano, I've said when the sprite is clicked, it will create a clone and do some other random things. So let's see what happens when I start doing that. And you see they're creating lots of different clones, and they're doing some interesting things. This program isn't really a useful program, but it's a neat thing to do to try and showcase how you can kind of control things. Obviously, using those control blocks and those repeat blocks. One thing that is really important starting at this level, especially kind of from a teacher's perspective, but students listen up too, is that often when people use Scratch, they decide just to copy other programs. We shouldn't be doing that all the time. It's a great way to learn and to see what people have done, but to prove that you've actually understood how to do these, you'll need to write your own program from scratch. Again, pun intended, from a previous video. So hopefully now you can see that the difference between progress outcome 2 and progress outcome 3 comes in the interactivity of your program, so that the user can do something once it's started, even though if it might be a minor thing, and that you're showing that you can kind of simplify the code by putting it into loops so that you don't have to constantly be writing these big long programs like the one I had shown you in the video on progress outcome 3. Well, until next time, happy programming. Don't forget, like, comment, and subscribe. Thanks for watching.